At the core of a glowing nebula, newborn stars blaze with fierce ultraviolet light, sculpting their surroundings in waves of energy. For decades, such regions were thought inhospitable to the birth of planets, too violent, too unstable. But with the unparalleled vision of the James Webb Space Telescope, that assumption has been overturned. Against the odds, the cosmos is proving itself more resilient and resourceful than we ever imagined, revealing worlds forming in places once deemed impossible. The Lobster Nebula, located 5,500 light-years from Earth, is among the galaxy's most dramatic star-forming regions. Here, more than 20 massive stars blaze with ultraviolet radiation, bathing everything nearby in energy strong enough to strip atoms of their electrons and erode delicate clouds of gas and dust. These clouds, known as protoplanetary disks, are the very cradles where planets are born. In such a hostile environment, the odds of survival for these fragile disks seemed almost impossible. Yet, the latest Webb observations have revealed something extraordinary. Planet formation not only persists, but thrives, even under these extreme conditions. At the center of this cosmic revelation is the young star XUE-1. Surrounding it, Webb has detected a compact protoplanetary disk, rich in dust grains and essential molecules, the basic ingredients for building planets. This disk orbits in the direct path of intense ultraviolet radiation from the nebula's massive stars, a region once thought to be a planetary graveyard. But what Webb has uncovered is a story of cosmic adaptation and tenacity. Using advanced thermochemical models and high-resolution infrared observations, astronomers have peered into the heart of XUE-1's disk. They found that, despite the relentless bombardment of radiation, the inner regions of the disk remain sheltered, dense, and rich in solid material. In fact, the amount of dust in this single disk could form at least 10 Mercury-sized planets. This is a staggering revelation. It means that even where radiation rapidly erodes the outer reaches of a disk, the inner sanctum can survive and continue the ancient, intricate dance of planet formation. The implications are immense. Previously, astronomers suspected that only the calmest, most protected regions of space could give rise to planetary systems. But now, the boundaries of possibility have expanded. If planet formation can endure within the ultraviolet storms of the Lobster Nebula, then similar processes might be unfolding in countless unexpected corners of our galaxy. This breakthrough helps explain a growing cosmic puzzle: why planetary systems are so common, even around stars formed in wildly different environments. For years, surveys have shown that exoplanetary systems seem to flourish around stars of all types and ages, in nebulae both quiet and tempestuous. The Webb discovery offers a crucial piece of this puzzle, revealing how nature finds ways to protect and nurture planet-forming material, even when exposed to conditions that should, in theory, sweep it away. Eric Feigelson, a leading astronomer and professor at Penn State, summarizes the significance of this finding. These discoveries support the idea that planets form around stars, even when the natal disk is exposed to strong external radiation. It's a testament to nature's ingenuity, a cosmic strategy where planet formation migrates inward, concentrating in the disk's most protected regions and ensuring that the seeds of planets can survive even as their outer layers are stripped away. The work at XUE-1 is more than just a triumph of observation. It's a demonstration of how the latest astronomical technologies are transforming our understanding of the universe. The James Webb Space Telescope, with its infrared sensitivity and immense resolution, allows scientists to dissect the chemical makeup of protoplanetary disks in unprecedented detail. By analyzing the light passing through and emitted by these disks, researchers can identify not just the presence of dust, but also the specific molecules, such as water, carbon monoxide, and complex organic compounds, that are essential for the development of planetary bodies. And so, the study of XUE-1 opens up a new era in the search for planetary origins, Now, astronomers can confidently target even the most luminous and energetic nebulae in the galaxy, knowing that planet formation is not confined to gentle nurseries alone. The resilience of these disks hints at a universe where planets are not rare exceptions, but a common outcome, emerging from chaos, adapting to adversity, and thriving beneath the glare of the most massive stars. As Webb continues to probe the cosmos, each new observation adds to our map of where and how planets can emerge. It's a search that spans not just the serene outskirts of star-forming clouds, but also their most turbulent hearts. Every protoplanetary disk detected in such extreme conditions is a testament to the tenacity of planetary formation, a process that, against all odds, finds a way. This discovery also reshapes our expectations for what kinds of worlds might be out there. If planets can form in the high-radiation environments of places like the Lobster Nebula, they might exhibit unique properties, different atmospheres, compositions, or evolutionary histories compared to planets formed in more gentle cosmic nurseries. Our catalog of exoplanets, already numbering in the thousands, may soon include worlds born in the most unlikely of places. The journey to understand planet formation is far from over. With every new insight from the James Webb Space Telescope and its successors, we peel back another layer of cosmic mystery, revealing a universe more dynamic and surprising than we ever imagined. The story of Xue-1 is just the beginning, a single chapter in the ongoing exploration of how stars and planets come to be and how life's potential footholds are scattered across the galaxy, even in the places we least expected. What does this discovery mean for our view of the cosmos? For decades, astronomers believed that the most violent stellar nurseries, those drenched in the ultraviolet glare of massive young stars, were essentially barren when it came to planet formation. The prevailing theory held that these high-energy environments would strip away the delicate material needed for planets to coalesce, leaving only isolated stars with little chance for worlds to form around them. Yet, with the James Webb Space Telescope's extraordinary sensitivity, we see the universe rewriting its own rules. The protoplanetary disk around Xue-1, located in the heart of the Lobster Nebula and exposed to a barrage of ultraviolet radiation from more than 20 massive neighboring stars, has upended this assumption. Here, Webb's infrared instruments have detected the signature of solid material, enough to potentially form at least 10 Mercury-sized planets. This isn't just a technical footnote, it fundamentally changes how we think about the galactic landscape and the potential for other worlds. Advanced thermochemical models, paired with Webb's observations, reveal something fascinating. The outer regions of the disk do erode under relentless radiation, but the inner regions remain shielded, dense, and full of the molecules and dust grains essential for planet formation. It's as if the disk adapts, evolving a more compact structure that's better able to weather the high radiation storm. This resilience is echoed across the galaxy, helping to explain why exoplanet discoveries are so common in places previously thought inhospitable to planetary birth. And the implications go even further. If planet formation is robust in these extreme environments, then the diversity of planetary systems in our galaxy may be even greater than we've imagined. The sheer number of stars forming in intense nebulae, like the Lobster, the Orion, or Carina, means that millions, perhaps billions, of planetary systems could be taking shape where once we saw only stellar chaos. It also suggests that the conditions for life, at least the raw material for it, might be seeded far more widely than our models previously allowed. This revelation is not just a single data point. It's the beginning of a new era in the study of planet formation. Researchers are already planning follow-up observations using Webb and other telescopes to examine similar disks across a range of environments, from the quiet outskirts of molecular clouds to the tumultuous centers flooded with radiation. Each new observation helps astronomers build a more complete picture of how planets assemble, migrate, and evolve over time. The ultimate goal, to understand the full spectrum of planetary birthplaces, from the calm to the extreme. Let's put these findings into a larger context. Recent discoveries have shown star systems with as many as 7 potentially habitable planets, and now, thanks to Webb's observations, we know that the environments where such systems arise are even more varied than previously thought. Planet formation is not confined to gentle, sheltered corners of the galaxy. It is a process that thrives under adversity, adapting and persisting against the odds. This resilience increases the chances that rocky planets, and perhaps life itself, could emerge in a stunning variety of cosmic neighborhoods. The pursuit doesn't stop here. The James Webb Space Telescope will continue to be our window into the hidden processes of planet formation, peering deeper into nebulae and star-forming regions and pushing the limits of what we know. Future missions, building on Webb's legacy, will bring even more powerful tools to bear. Instruments like the Nancy Grace Roman Space Telescope and next-generation ground-based observatories will join the search, using advanced spectroscopy and imaging to parse the fine details of protoplanetary disks and their evolution. With every new observation, we gather more evidence that the universe is not only more dynamic, but also more hospitable to planet formation than we ever dared to dream. The story of XUE-1 is a striking reminder that our models must evolve alongside our expanding view of the cosmos. As we find planets forming in the most unlikely places, we're reminded that the processes that shaped our own solar system are at work all across the galaxy under conditions both familiar and utterly alien. The next big questions are already emerging. How do these resilient disks give rise to different types of planets? What unique chemical signatures do they leave behind? Could we be on the cusp of finding new Earth-like worlds in regions we once overlooked? Each answer brings a cascade of new mysteries, fueling the relentless curiosity that drives space science forward. As we look up at the night sky, we now know that the tapestry of stars is accompanied by a hidden multitude of worlds in the making, even in the brightest and harshest stellar nurseries. Thanks to the James Webb Space Telescope, we're witnessing the universe's ingenuity firsthand, how it forges new worlds in the crucible of radiation and chaos. If you've enjoyed exploring these cosmic discoveries with us, make sure to like this video and subscribe for more content like this. The universe is full of surprises, and together we'll keep uncovering its secrets, one discovery